Okay, so we're back here, and the good news is that the first part did record, so that's good. And the other good news is, as you can tell, is that we have audio now. We can. So we have audio, so we're good there. The bad news is we lost a bunch of people, but hopefully they'll come back and figure out that I'm back online again. So that's what's up with all that stuff there. And this legato mode. There we go, play mode, change that to last. All right, there we go. So, right. Okay, so we just talked about, the first part was all about the history of synthesis and stuff like that, and I brought us from the past up until the present, so now we're here in the present, and now what we're going to talk about is synthesis itself. There are there's basically three main building blocks of synthesis. Let me go ahead and open up my here, go to teaching, and this notes, and go to the synth basics. Yay, synth basics. All right, so basically, here, let me just skip this real quick and just go in here to the basic building blocks of synthesizers. We have an oscillator, we have a filter, and we have an amplifier. And these are the three main parts of all synthesizers. Anything that makes sound that's electronic basically has an oscillator, has a filter, and has an amplifier. And identifying these main parts is what's really, really important to understand how to do sound design. So those are the three main parts. Now let's just back that up for a second and talk about sound design. If you said to me, Tony, I want you to make me some kind of sound that sounds kind of like a harp. Okay, well the first thing I do is I would think about, what does a harp sound like? Does a harp go psh? No. Does a harp go wah? No, a harp goes bing. That's what a harp does. Bing. It starts with a fast attack and then trails off over time. Does a harp go bing? No, that is not what a harp does. And so in order for me to make a sound for you that sounds like a harp, I have to think about, what does a harp sound like? And a harp starts fast and dies off over time. Beep, like that, okay? So that is the envelope that we're talking about. The envelope is thinking about, like, what does a harp, how does it sound? Does it start fast? Does it start slow? Does it go loud, soft? Like, what is it doing? That's the envelope. It's the shape of the sound's loudness. The next part we have to think about when we're talking about like making a harp sound for somebody is the timbre. And I know it looks like timbre, but it's pronounced timbre. And that is the brightness or darkness of a sound. It's defined by the harmonics of the sound. So what that means is, if somebody says, make me a harp sound, in my head, do I think of a sound that goes or a sound that goes or a sound that goes? No, I think of a sound that goes, it's got like a hollowness to it, but a roundness at the same time. Boom, like that. It has a bit of brightness on the beginning, and it gets a little bit darker as it fades away. And that's because of the how the string is played. It's played by plucking it with your finger. Bing! And so it kind of starts bright and gets darker as it fades off. So if I want to make a sound, I'm going to think of these things. And this is what goes into all sounds. Every single sound that you can imagine is really just the envelope and the timbre. What does it sound like over time? And how bright or soft is it? That's it. That's really it. And it gets, I say that's it. It gets a lot more complicated as we go, but that's the basis of it. Okay, so let's just real quick take that and apply it in here. I'm just going to use this synth that we've got up here, and I'm going to make a real quick harp type of sound. So the first thing I'm going to do is I'm going to turn off all these things. I'm going to go ahead and turn the volume down on these. Even though they're off, I'm just going to turn the volume down. We're going to start with just one waveform. We're going to start with a square waveform. And we're going to leave the cutoff frequency all the way up, filter all the way down, contour, nothing. And we're going to start with sustain level all the way up, sustain level all the way up, and attack all the way down and decay all the way down. So now, right. So there's our sound right now. And what I'm going to do while I'm making this sound is I'm just going to go ahead and quickly play in some kind of a cool. So we got that. I'm just going to play in something. Cool. I'm going to make that all legato. And what I'm going to do is, as that plays, I'm going to make it sound more and more like a harp. So first thing I'm going to do is start with my envelope. I always want to start with my envelope before I start messing with the timbre. So I start with the shape of the sound, and then I start messing with the color of the sound. So I'm going to go in here, and I'm going to explain all this stuff in just a minute. First of all, I'm going to do is I'm just going to show you how quickly I can do it, and then we're going to talk about how all these pieces of the puzzle come together. Cool. I do not want my glide on. And there we have a basic harpy sound. Yeah. And we could go from there and make it, sound more realistic to a point, but it's an analog synthesizer. It's not going to really get to sound totally like a harp, but it's harp-like. Put this up an octave. Nice. Okay. And that's just using one oscillator and the filter and our amplifier. And that's about it. Super, super basic, but it sounds kind of harp-like. Okay, as Agent Orange said, pluck. This is a category of sound. It's actually a new category of sounds called plucked sounds. The term plucked for a category of sounds actually didn't come around until EDM started being a thing around 2012 or so. But here it is, it's here. Okay, so what we're going to do is take a step back again, and we're going to talk about all the different parts that I used to make this plucked sound. So we're going to go in here to this, and we're going to talk about over here, the oscillator. Let's go back to this one more time. So we have our oscillator, we have our filter, and we have our amplifier. So the oscillator creates the sound. It's whatever makes the sound. And this is where you get different synthesis types from, and also like samplers and stuff like that. Even though a sampler is not a synthesizer, they both have oscillators, filters, and basically an amplifier. And the oscillator on a sampler, not that we call it an oscillator, but it would basically be the instrument that's the played sample. In this case, with a synthesizer, an oscillator makes the sound from scratch. So before I hit a key, there is no sound. When I play that key, it's making the sound happen right there. There's no recording of a sound that's happening. And that's the difference between a synth and a sampler. A sampler is using recorded sounds assigned to the keys on the keyboard, and I can play them back, recorded sounds. But a synthesizer is just making the sounds from scratch. Now this is a digital synth. It's my software synthesizer, so it's actually using math. It's actually using computer code to make the sound. If it was an analog synthesizer, it would be using electricity to make the sound. So the oscillator makes the sound, and then that sound goes into the filter. And the filter shapes the harmonic frequencies of the sound. So the sound starts off in one way, and it goes into the filter, and the filter changes the harmonic frequencies, meaning it usually makes it darker. It shaves off frequencies. That's usually how they work, and that's called subtractive synthesis. But you can have different types of filters, so it's not always subtractive synthesis. It's not always subtracting frequencies away. Some of them are adding frequencies in, and we'll talk about that a little bit later. The amplifier shapes the loudness of the sound. So the amplifier is what makes it start loud and then get softer over time. But it's not just the amplifier by itself, and we're going to come back and talk about what's helping out the amplifier to do that in a few minutes. So let's go back to the oscillator. There are different types of waveforms that the oscillator uses, especially when you're talking about analog gear. And that's the sine wave, the triangle wave, square wave, and the sawtooth wave. And then we have noise. Now I've got on here, it starts off with less harmonics and goes to more harmonics. What that basically means is when you have less harmonics in a sound, I'm going to go ahead and turn this all the way up. Okay, so here's our sound. If I start over here on the left, that is what we call a triangle wave. And you can see the little window that pops up that says triangular width, whatever. So you can hear there's a little bit of brightness in there, but it's a pretty dark sound. I just turn my volume up. Okay. It's up as loud as it can go. Okay, cool. So it's a pretty dark sound. If I go over here, this is like a saw triangle. Gets brighter. Go here to a sawtooth waveform. Super, super bright. If I go to a triangle, a square waveform, pretty bright. And then the rectangle, it's like a square with a different pulse setting. Different type of brightness. And then over here, kind of a pinchy, bright sound. Right? And there's our different types of sounds that we have to work with on analog synthesizers. Now, of course, this is not an analog synthesizer. This is a digital synth. It's a software synthesizer. So everything it's doing is using computer code to do it. But I hope you understand what I'm saying. If you had an analog synthesizer, if you had a Moog Model D, it would sound basically like this, okay? So these are the ones, these are our options. We don't have any other options. This is the starting point here. But what happens is this signal, goes into a filter. Here's the filter. Oops, I want you. Goes into the filter. And the filter is over here on this side of this keyboard, over here. So what happens is the signal travels from here, oscillator 1, over here into our filter. Now this part here in the middle is our mixer. We're going to come back and talk about that in a second. But it goes from our filter into our, it goes from our oscillator into our filter over here. And now, I'm going to just move I'm going to get my computer screen set up here, if I can. Let's see, I can only move it to the right and up. I can't move it down to the left. So let's see if I can get this set up correctly. I don't need the range. I want the waveform, and I want the cutoff. Oh. Ah. Why did that turn on? I did not want that to turn on. Here, let's do it like this. Like this? Okay. So there we go. So you can see everything on my screen. So now, if I turn my knob, here, this knob here turns this one, and this knob turns my filter emphasis. So what I can do here is I can show you as I turn my frequency down, it's basically subtracting out the high frequencies. And that's because this is what we call a low-pass filter. A low-pass filter means that it's letting the low frequencies pass through. I'm going to show you a picture of this in just a second, but I don't want to mess up my beautiful screen that I have set up right now. So it's going to let my low frequencies pass through. So what I do is I just take this, and as I turn the knob to the left, it's shaving off those high frequencies. Now, you'll notice you can't really hear that well because this waveform doesn't have a whole lot of harmonic frequencies up high anyway. So let's go ahead and choose a different waveform. I'm going to use the sawtooth wave. I'm going to turn it. And you can see as I mess with my frequency here, as I play with the frequency, you can hear it getting really bright, or you can hear it getting really dark. That's because I'm just shaving off the high frequencies. All right, I can make it sound like a science experiment. Right, pretty cool stuff, huh? All right. So now, so we have that one there, and different waveforms have different sounds and how they react with the cutoff frequency, kind of. So this is a square wave. But it's all just shaving off the high frequencies there. And that's why we call a Model D synth is a subtractive synthesizer, because you start with the oscillator has a certain amount of harmonic frequencies in it, and the filter subtracts harmonic frequencies away from it. Now, the Moog synth only has one type of filter, and that is a low-pass filter, this Moog synth, I should say. Different Moog synthesizers have different filters on them. And that's how it is in general. In general, when you're talking about different synthesizers and why different synths cost different amounts of money and why people prefer one synth to another synth, it's because they like the sound of the oscillator and the filters. Those are the two main parts that you're judging the sound from. So how does the oscillator sound? Does it sound really nice and warm and big? How do the filters sound? What do the filters do to the sound? How do they affect the sound? These are all things that are that separate different synths from other synthesizers. Okay, so we have that there. So the oscillator goes into our filter, and then the filter goes into our amplifier. Now the amplifier is right over here. This is our output knob, and down here we have the loudness contour, which we're going to come back and talk about. But if I want to make this sound louder or softer, I can make it louder or softer right there. I can set it up, and there's 0 dB. I can set up right there to make it louder or softer. But that's the sound as a whole. Now, that's the basics right there. What we've done with what they've done with this synthesizer here is this synth actually has 3 oscillators. So we've got the one oscillator that we're playing with right now. I'm going to turn this one down to. Let's play my. Okay, so I have that little line there. What I'm going to do is I'm going to now turn on these other oscillators here. This one here. I'm going to fade it in. Here's my mixer for this particular oscillator. This is oscillator number 2. And you can hear it. You can hear it playing a different octave here. and I can change the waveform. Now what's cool about this is both of these oscillators, everything from the mixer section here is going into our filter. So I'm going to go ahead and pull up this last one in here real quick. We're going to put this an octave up. Oops. Now I'm going to go over here to my filter and shave off the high end. And you can see how I can totally shape the sound here. Huh. Yeah, that's interesting that you say that, RJ. Like a video game version of the Beatles because, yeah, kind of, yeah. Okay, so this is now what I can also do with this is I can take this oscillator here, number 3, and let's go ahead and pitch it up. Neat. And if we want to put that pluck back into it to make it sound more plucky again, there we go. Turn this down. Fade this around. And you can do some cool stuff with the sound just like this, just with messing with these controls, these few controls. Okay. So that's our oscillator section. And each oscillator works exactly the same. So it's not this big mysterious thing. It's just the oscillator makes the sound and then that sound goes into the filter. Now in this case with this synthesizer, we only have one filter. All the oscillators gets mixed together into one unifying sound and then they go into the filter. All right, let's go back to our preview. And let's go in here. So let's talk a little bit about the amplifier. Now the amplifier is what controls the loudness. The amp is responsible for turning the sound generated by the oscillator on and off, louder, softer. So the oscillator, depending on the synthesizer, some synthesizers work like this, others don't. But a lot of them, especially the older ones, and especially the modular synthesizers, the oscillator is just outputting constant sound. So if I just plugged my oscillator, connected it up to my speakers, like is shown in the first diagram there, then it would just be a constant sound. But you stick an amplifier in the middle there, and then you connect a keyboard to it, and you trigger the keys on the keyboard, and it opens up the amplifier. It makes the amplifier like play or not play. So that's how you can make the sound start and stop. The amplifier, especially on modular synths, is its own thing. That's basically letting the sound come through and making it louder and softer. That's what the amp section does. And a lot of times, not all the time, but a lot of times, the way this works is that the amp has a knob and it has like a level, let's say that I have this level here, and I've got 0 down here, which is no sound, and up top I've got 100%. So this 100% is the max level that we can deal with. And so the sound is moving between the 0% and 100%. It actually doesn't go above 100% because that's the maximum output level. This is going to be really important in a few minutes once we start talking about things like envelopes and LFOs and stuff like that. So we're going to come back to that. Next is our filter. The filter, we have, a lot of times we have 4 different types of filters. With this synthesizer, as I already showed you, you do not have 4 different types of filters. You have one filter, and there's no choice. That's just the only filter you've got. Fortunately for everybody involved, it sounds amazing, but there's a few things you have to understand about it. First of all, you have to understand that it is a low-pass filter. Low-pass filter is this one right here. Right up and here. Oh, I can't highlight it. This filter right here is the low pass. So what this diagram is illustrating is that the audio is coming through the filter. It's this low part down here. If I'm in a high pass filter, the high pass is letting the high parts pass through. The band pass is letting a band of audio pass through. So the low pass is letting all the stuff in the low end pass through. The low end is, wait, on your, over here, I guess. Okay, that's what the low pass is doing. And the high pass is letting all the high frequencies through. Band pass is letting just the stuff in the middle pass through. And then the notch is actually getting rid of certain ones in the middle. So that's how these different filters work. But on the RJ, I know you're messing around with the iPad. And those of you who actually got the iPad Moog, Mini Moog synth, you can mess around with it as well. If you have Arturia, you can mess around with this. If you have the, I know somebody said they had the subsequent 37. I think it was Agent Orange. So you said you have the subsequent 37 at home. You can mess around with it on there. The subsequent 37 is basically set up the same way as the Mini Moog. They all kind of have the same history. And this has one filter. That's it. No multiple filters. Okay. We'll talk about some other synths in a little bit. I'll show you some synths that have different filters so you can see some differences. Yeah, cool. Okay, I'm glad I remembered that. Yeah. All right. So that's what's going on there. On the filter, you have a couple of different controls. You have your frequency cutoff and you have your resonance. And if I play it, the frequency, of course, adjusts which frequency is being passed through. And the emphasis is showing us it's like a peak at the cutoff point. Zane, you're gonna have to tell me your name, dude. You have this thing going on where you think I remember your name, but I don't. I'm sorry, buddy. Tell me your name. Tell me your name, your full name. I must have your full name. I need your full name. If you don't tell me your full name, I will not mark you here. Come on, dude. Thank you. Come on, dude is not the way to get me to remember your name. Just answering the question is the way to get me to remember your name. John Sweeney. Boop, boop, boop. John Sweeney. There we go. Cool. All right. Sweetness. Thanks. All right. So, learning the envelope helps you to fully understand compression. Yeah, I understand that. Actually, learning how the envelope works helps you to understand compression. Totally. Yep. Good. And whatever helps you understand compression, because compression can be a pain. All right. So, filter controls. So this is what it looks like here. I've got my low pass filter with no resonance, and then if I put resonance in it, we can see it's doing this thing right here. Now let me show you this in Ableton Live. What I'm going to do is I'm going to bring in here the EQ8. I'm going to pop it up, boop, like that, and let's take a listen. Okay, so actually, let me make this into one. Turn this off. Okay. Okay, cool. So we got that sound there. And you can see it's got all these frequencies up and down the whole spectrum here. Just make that bigger. There we go. See all the frequencies. Now, if I take my cutoff and I turn it down, and I'm not going to show you the screen, I'm just going to turn it down while I'm messing around with the knob. You can see it's actually getting rid of those frequencies. See how you can see the frequencies actually disappearing. If I turn it back up again, you can see the frequencies come back. And that's a really cool thing. That's like, to see that is really helpful, I think. Now, what I'm going to do is I'm going to turn up my resonance. And you can hear and you can see and hear that difference. I had to turn it down a little bit so it wouldn't destroy our ears. But that's a really cool thing to be able to see that right there like that. Neat. All right, so that is the resonance, or also called peak. Some filters, not this one, but some filters have what we call a slope. And the slope determines how quickly the filter cuts off at that frequency. So there's different ways that these do this. Some synthesizers have the slope listed as a 4-pole slope or a 2-pole slope, and some of them have dB. If it says dB in the name, then what that means is it's how many decibels per octave are cut out of the frequency. So if I look at this here, let's take a look at my screen here real quick. If I have a low slope, that's 6 dB. And that means that for every octave above the cutoff frequency, it takes off 6 decibels. So the slope is very gradual. It's like this. So here's the starting. Sorry, people on 6th Avenue are angry. So if you start off here, and then when we go an octave up from that, it's going to be 6 dB down, which is like right here. And you go up an octave from that, it's going to be another 6 dB down. Boop. So the slope will be very gradual. If you have a cutoff filter that has a cutoff of 12 dB, well, if this one here is 6, then 12 would be like right here, right? So it's going to go down more. So the slope is going to be steeper. And if you have 24 dB, it's going to be like this. So the slope cuts off a lot faster. So that's what that means. That's what the slope is. So if we listen to it, I'm going to have to bring up a different synthesizer to actually hear that. Let's get a different synth. Let's get analog. I'm going to pull up analog here. This is the one that comes with Ableton Live Suite. I'm still laughing at the "come on, dude." That's so funny. Okay, here's this. And let's turn our release down. I'll turn this down a little bit, oh my goodness. Okay. I'm also going to turn it down so my velocity is not being messed with by the, where is it? Right here. Okay, so my velocity doesn't affect. I should play these notes into a sequencer, C, E. We can do that later. I just want to play one note at a time right now. I just want to play some notes, easy notes. So over here is my shape, so I can change the shape. Why are we still hearing you? There we go. Cool. There's my sine wave and sawtooth, square, and then noise, which is just noise. Okay. So, have this. Okay, so we have that. So with this sine wave, we're not going to hear any difference. If I go over here to my filter, really doesn't do anything at all. But so let's go ahead and use the square wave because it's less annoying. And if I mess with this here, you can see it pulls things away. Let's see, where's my... Oh, wait, hold on, let's go back to this one here. So here's my filter, my frequency, right? And we can see in here with our filter, I have a few different options of different filter types, and that's why we're using this one. This analog synth doesn't sound nearly as good as the Arturia one. It's okay. I prefer the Arturia one. But this one does have more filter types in it that we can mess around with. So low pass is like this. The low pass, so we got 12 and 24. So here's the 12. And here's 24. Hold on, turn that down. There we go. And 12. So 12, if you listen, you can hear more of the high frequencies with 12. You can hear there's high frequencies in there. And this gets rid of them. It also changes the sound quite a bit, actually. I'm surprised how much it changes the sound. That's interesting. Now, that's a low pass. That means that we're still shaving off those high frequencies. Right? Now what if we put a high pass in here? So now we're shaving off the low frequencies. Right, we're shaving off those the low frequencies. And again, if we put it in 12, we should hear more of the low frequencies in there. So here's this. Like that. And hear how it changes the sound. This one's actually changing the sound quite a bit between the 12 and 24, which I never really noticed. I never really played with it that much, paying attention to it with this one here. Some synthesizers don't change the sound that much. And then you've got band pass. Now band pass, this is like in the middle. It's just like I said before, it's letting a band of frequencies through. And now, why are we not hearing anything? What happened? Let me turn this up. Interesting. Interesting, that's not doing, that's weird, yeah. All right, so. Oh, somehow my shape got changed, that's why. It's like, what's going on? There we go. There we go. So you can hear the bandpass. When you go up high, there's no low frequencies. When you go down low, very few high frequencies. And let's change that. There we go. Cuts off more of those things. Right, so you can see what that sounds like. And then you have also this formant one. Oops. Which is like an A, E, I, O, U. It's like a vowel. Which is like, was really widely used for like a lot of like bass music and stuff like that a few years ago. Cool. How are we doing with the filters? Feeling pretty good about them? Awesome. All right. Where are we in here? Cool. Yep. Great. So that's the basics of that stuff. Actually, I'm going to stop here because the next part we're going to talk about is, here's a little preview, but we're not going to get into it too much. But the next part, let's say that I want to make my sound. Whoops. Here, let me get back to Ableton Live over here, and I'm going to use this Mini Moog, and let's see. Right, if I wanted to make this, if it do that, right, if I wanted to make it do that automatically, I can set up LFO to control it to make it sweep my filter automatically, or the envelopes here. And Jerry, you talked about envelopes earlier. We're going to come back, and now that's what we're going to talk about right after the break, is the envelopes and stuff like that. What's up, Anthony? How you doing? And then RJ, I guess this on this Moog, the filter emphasis is the resonator. Yes, filter emphasis is resonance. Mm-hmm. And then contour is your envelope amount. That's what contour means. It's like the envelope amount. Cool. Let's see. Well, let me get you in here, Anthony. Sweet. Cool. All right. Anybody else before before we take a break? Anybody else is not on this list here? And somebody want to text Jeffrey Applewhite and let him know that class is happening. Would be great. That'd be pretty awesome. But anyway, so let's take a break. Go ahead and be back at, I guess, 4 p.m. Yeah, I'll give you a couple extra minutes. And because it's Friday, y'all can decide if we want to stick around the whole time, or if you want to go like a couple minutes early or whatever, just because I know there's a lot of things calling you outside. I know it. I know there are so many things that you want to get out there and do. So think about that. But anyway, let's take a break. Be back at 4 p.m. I'm going to stop recording right